So thank you all for coming. Yeah, it's been quite a fun conference, Barcelona. It's my first time here, so excellent being here. And thank you guys. Thanks, Source. And yeah, so today we're going to be talking about hacking SAP BusinessObjects. So that's the goal of the talk. We're going to go through some methodology and really make a talk that's useful for applying these sorts of theories to penetration testing. And that's sort of the essence of this talk. So this is how we're going to approach it. We're going to go through the overview and basically break down what is SAP BusinessObjects, and then start talking about a methodology for understanding what types of things, if you're a pen tester, would you want to focus on during an engagement. And then from there, we'll talk about reconnaissance, information gathering, and actually looking at some different attack vectors which we've sort of defined over our research. So our little disclaimer, obviously, if you're going to do any of this stuff, you need written authorization to do so. So, sort of following in the normal standard process. So starting out, who are we? So I'm Jabra, also known as Josh Abraham. I code in Perl, and I also do some security research and pen testing. And I got a blog and Twitter and all that stuff. And this is Will.
I'm Will. I'm also on the Twitter, down there, also penetration testing for Rapid 7.
2 underscores for Will. So. Yeah, but we're not here to talk about us. We're not even here to talk about our company, Rapid 7. We do some stuff. We make a vulnerability management product. We support open source software, Metasploit, W3AF, and we have a professional services team. What we're really here to discuss is an overview of SAP BusinessObjects, talk about some different attack vectors, define it, make it really practical and useful for everyone in the penetration testing field, and then looking at some new attack vectors and new particular areas that we found very interesting during our research. So yeah, breaking stuff is cool, and standard disclaimer, get the written authorization permission first.
So obviously SAP, giant company, arguably the #1 business software company in the world. Huge product lineup. Huge product lineup. ERP covered yesterday. A lot of different interesting stuff. Once accumulated a bunch of different vulnerabilities for different products in their product lineup. Our focus is business objects, as Josh said, business intelligence tool. So pretty much what it sounds like. Taking vast amounts of data, organizing it, doing stuff with it, so analyzing it, reporting on it, and then providing many different ways to interface with that data. So in their little bio, it's described as flexible, scalable, accessible. So flexible, it can be loaded on many different OSs. Scalable, different portions can be put in different places and distributed. And then accessible, there's a lot of different interfaces for the product. So this is the architecture overview. It's huge. There's tons of things going on here. But to kind of get your bearings on it, the bottom here, so the cubey thing and the cylindery thing, that's where the data lies and is organized. In the middle here, this is the area that does stuff with the data. So this is analyzation, reporting, process job servers, and then a little bit higher up is going to be more of your interfaces. So to kind of show really the tip of the iceberg, the interfaces we focused on are the 2 in red. So just these 2 right here. The first was kind of in the middle, the central management console. Basically, it's administrative interface. So anything dealing with administration, accessible via the web server, user group creation. Really powerful though, because you can administer the rest of business objects. Second, web services, which was kind of on the left. Brokers requests from the browser to different parts of business objects using the bus, which you saw in there. Again, a lot of different stuff that can be done with it.
So to understand business objects and to understand SAP, a large portion of all of their software is based on the idea of the service-oriented architecture. And what that basically means is interacting with web applications through different means, and not just using a traditional web application. So you need to look at abstraction mechanisms, and also looking at SOAP as the primary method for actually interacting with these applications. So if you're not really familiar with SOAP, it's basically like HTTP, but you're going to add another layer of complexity, and you're going to add XML on top. And then from there, you're looking at either like an object-oriented representation of interacting with those back-end databases. So similar to like an API, but it's sort of all done over HTTP. So this is the sort of the traditional. So you have the user on the left or on the right there, and he's basically making requests to this web server, and that web server on the back end is actually transmitting and communicating with web services. So that could be multiple different systems, and you really can think of sort of a ton of different communications that can go on and represented just within this inside the web services diagram. You can really think about if you're transmitting to various other systems and they're querying out to other systems, we're sort of oversimplifying it and sort of making it really clear. So for those of you who are not familiar with the service-oriented architecture, this is pretty much how it breaks down. The important thing to note here is also it was sort of built under the idea that if you had legacy systems and they weren't built with the web application in mind, you could actually communicate with those systems and then make queries based on the architecture here. So breaking down SOAP, it's basically an API representing XML over HTTP. That's the essence of the idea. So if you're thinking about the OSI layers, you're going up above HTTP multiple layers and multiple steps. So you're adding XML, you're adding a representation around this particular mechanism for communication. And then you can also add on top of XML representations for security. So if we wanted to encrypt messages and handle particular types of communications in specific ways, if we want to do key exchanges to verify that this user actually wrote this message, that would actually be included within the message body. And then the other being SOAP, which is basically the representation, limiting down the number of possibilities within inside that XML representation. The way that the data definitions are represented, it's called a WSDL, which basically just gives you a representation for understanding those different types of requests that you would be making and communicating with a web service. So you understand that you have to understand what the data definition is first, and then being able to construct something that would be able to understand and make these requests in a manner that the service on the back end would understand. The last item here is just another piece, which is UDDIs. It's basically just referencing a particular web service. So it sort of gives you like a pointer to a web service and understanding that, okay, here's where I need to actually go to get more information about this particular service. Next is sort of like a threat model around SOAP. So understanding that when you talk about web services, there's so much complexity in each one of the different elements that you really need to break it down into a logical model, so that when you go in to do a pen test and you say, we need to talk about how you're securing your web services, they don't always understand what you mean by security. And what does that actually break down to? Well, we found a great reference in the Hacking Web Services book, which basically just said, okay, here are 4 different layers that would break down the security for a web service. And then if you're looking at testing each one of these layers, then you've defined what you mean by security, so that it's actually referenceable and you can give good resources to the developers and saying, look, in transit communications, specifically, when we talk about things like SSL, what type of attack would that actually prevent? And then, the other layers, basically looking at when you're parsing the responses, so that's the engine itself, and then the deployment of the actual services, are the controls set up in such a way that this user should be able actually define, so you're setting up your roles and such. And then the user code, so basically being able to say, okay, well, does this actually perform the functions that I wanted it to perform, this web service? So when we talk about SSL being one example, what type of security would SSL provide to a web service? Well, the idea of all this messaging and such is you have multiple different nodes. So the SSL would provide the communication between nodes, but if there's a particular node that you don't trust or you trust less than others, then it's not actually going to give you anything. So you have to look at message layer security within inside the message to basically ensure that somebody's not tampering with your message or either reading your message if that's the attack that you're worried about. So really just breaking down what do people need out of security, and this sort of we ran into a lot of clients who basically saying we don't understand what this is or what's the value that this is adding. So message layer security, it adds a ton of work because it's overhead into every single message body or the representations for those messages. So when you think about actual communications, there's SOAP messages are similar to email, so they'll just transmit from one node to the other, rather than just like a standard web server where it's just communications with one particular end device. And that's why SSL works for particular customers and not for others, because you have node 1 transmitting to node 5, and then, the communications, if you have a malicious administrator on node 3, maybe he's able to read your message body, and then from there it's, a negative impact on the confidentiality, integrity, availability of your data. So a little bit of a tools of the trade when you're testing web services. Obviously, from the QA side, they have a great product called SOAP UI, which is it's basically a tool to make a lot of the testing process much easier. So being able to make SOAP requests specifically to a web service, and then also you could build your custom tools to do something which is a little bit more complex. You want to automate on the QA side. And on the pen testing side, we do the exact same thing. We'll look at automation for specific types of attacks, and then obviously we want to get into one particular request and make a bunch of different requests. The other side of that is looking at using a proxy. And for web application testing, we've been doing this for a long time. But then we'll just basically make our communications from either the programming language or SOAP UI, which communicate over HTTP, and then we just communicate with our proxy. So from there, it's going to progress into leveraging a lot of the functionality of something like Burp Suite to be able to manually modify a particular request. So you get that fine-grained control that you're looking for. So here's a quick example in programming language that I don't program in often. But as you can see, it's just simply saying, here's the WSDL, create a representation that can interact with it, and then from there, just simply log the requests and communicate with this proxy on port 8080 so that I can actually look at those different types of communications, and then I can either replay the attack or modify one of the parameters, and we'll get into that a little bit later. But this is just simply making a request to take a look at some information from the stock web service. So as you can see, it's just using SOAP UI with a proxy, communicating over to Burp Suite, and then from there we progress easily enough. So with Burp Suite, you can obviously modify any one of the parameters, any information in here, and then use that with Intruder to basically do brute force attacks, whatever you want to do. You can also look at, maybe there's a session ID that's being generated somewhere, so you can pass that along to the sequencer and look at the pseudo-random number generators, verifying that they're in fact doing it correctly.
Kind of bring it back around before we start going to the threat model and attacking. Again, this is the architecture overview. These are the two interfaces that we researched and we're going through. And then the goal is to get onto the service bus and eventually gain access to what you're trying to gain access to, whether it be data at the bottom or using the system as a pivot.
So when you look at penetration testing, obviously a lot of, all of the attackers are looking at financial motivations, other types of motivations, but they're looking at, performing attacks that get a particular benefit for them. So from the pen testing side, we have to look at, okay, what am I trying to do and represent the attacker's different attacks. So we sort of leverage, based on our experience, based on our sixth sense, and basically feeling out what do I think feels vulnerable, but then also looking at defining goals to be able to determine what are you spending your time on. And then if you're constantly reevaluating what you're spending your time on, you're going to be much more effective in penetration testing. The other thing is that obviously penetration testing only gives you a snapshot in time. So after the engagement, it's sort of, obviously the only constant is change in any network. So it's an important thing to keep in mind. So we use the goal-oriented penetration testing methodology to help us determine what we spend our time on during an engagement. And this is sort of like our methodology that we based our research on so that we could demonstrate practical attacks for everybody using the penetration testing field. That was the idea. It wasn't just all theory. We're actually applying theory directly to make something tangible. So you're going to get a bunch of useful code and examples and things that you can take and leverage when you leave the conference. That's pretty much it. So yeah, this is your...
Yeah, lots of entry points. Again, examine a couple, associate different goals for different folks, like Josh was talking about goal-oriented pen testing. What are we trying to get to? What are we trying to achieve? If it's unauthorized access to information, remote exploitation of business objects to the server, uses an internal pivot, maybe using some administrative credentials you obtained, or is it information only? So version fingerprinting, or if you're seeing an old version, is that indicative of a lack of patching? So reconnaissance discovery, these are a couple of the web application interfaces for business objects. So CMC app, talked about before, it's a main administrative interface. The DSWS BobJE, which is the web services, not installed by default, requires deployment, InfoView app, and analytical reporting. So if you're seeing this is business objects is installed and you're going to use it in different ways. It also becomes useful when you start looking at the Google Doc. So a couple different ways for reconnaissance, external and internal enumeration. If it's a completely black box pen test, and you want to help the customer identify what they have exposed on the internet, you give them a couple Google Docs for that. Port and application-based enumeration, so scanning, trying to identify if they have business objects deployed. And then from there, version fingerprinting, either through the browser, through web services. So a couple of Google Docs here. In URL InfoView app, we'll pull up a few different interesting ones. And like I was saying before, let's say you do find InfoView app for some site. You can begin to try out some of the web interfaces. They're usually in consistent locations. It's unusual to change it that much. Crystal Reports, another interface. File type CWR. This one's kind of interesting here, and if it comes in a little bit later, but file type CWR in URL apps token. Another feature of Crystal Web Reports is you can put the password within the parameters. So if you search for file type CWR in URL apps password, you'll find index sites with the password actually in the parameter, along with the username and some of the internal IP addresses.
That's a win.
Fail. Just some more here for reference. So here are a few InfoView apps in URL gov. So these are deployed, they've been cached already. It's arguable, is your risk increased by this? Well, like any service, your risks increase by having exposed, although I don't really see the use in having it cached on Google. So port scanning internally, so like I mentioned before, the file type CWR in URL apps token. So what the apps token will actually provide is, you see down here, apps token equals internal :80 @token. So what that's specifying is the internal server to request, is this a valid person? But you can kind of abuse it, because typically that'll be on 6400, but if you say 80, it'll give one error message if it's closed versus 445 with another error message if it's open but just not able to communicate with it. So from there you can, one, begin to do pseudo port scanning. Two, you can start to identify different host names, so you can try dc.whatever for the host name. Also internal IP address scheming. All informational, really useful, can be leveraged later on. These are the unique apps, unique ports. So if you're scanning your infrastructure, you see these open, begin to look through them.
All right, so then on the other side of that is looking at doing actual version detection on the web application. So one of the pages that we found was accessible was this particular page, which basically contained the version information within inside one of the XML documents. So obviously enough, the server could actually spoof this information. So do you actually trust it? Well, probably you do, because usually I wouldn't see an administrator going and actually replacing this sort of thing. If you're spending the time to actually get it deployed, it's more work to actually modify that sort of thing. So keep going to the next one. The next one is actually doing a similar request over SOAP. So we can just simply request, give me the version, totally unauthenticated, and it'll just print you back to version information within inside the SOAP document. So what we did was, from there, we actually took that and we leveraged that in creating a Metasploit module. And how do we use it? Simply enough, just say use this particular name of the module, and then from there set that up on the internal address space, and then just go. So that'll use the DSWS BobJE interface to actually just make SOAP requests and just return version information if it's there. It's sort of like enumeration and such. The next slide is looking at username enumeration. Okay, we have this version, which may or may not be vulnerable. Maybe there's a username that I want to actually try to log into. So we can actually use the same sort of method to just basically query the web service with a SOAP request to be able to say, is this a valid username and password? So here's what the SOAP request looks like, and obviously you can see here the login administrator, password 1, and then from there it's authenticating against the system. You can also set it up with SSO, single sign-on via Active Directory. We didn't implement that sort of thing because of the fact that usually that would be tied back to an LDAP directory and that sort of thing. So here's how we use the username enumeration. Similar to the version information, you just set up the module, set our hosts, set username, and just go. Obviously, you can use a list of usernames if you wanted to. So this will be able to do the username enumeration for you. Now we're getting into the attack. This is the fun stuff.
First one, so BusinessObjects uses what we call CUIDs, basically a unique identifier for different actions. But one of the interesting things is it'll allow you to request a specific number of CUIDs. So what you can do is say, give me 100,000 CUIDs, please, repeatedly. Just keep asking for it. So the post request is right here, and then here's just an example of asking for 100,000 CUIDs.
So we put it right there.
What it opens it up for is denial of service, because you can just keep asking for them, keep generating through them.
And that's fully unauthenticated, right? So.
Yeah. Also, so BusinessObjects can be commonly paired with Oracle. So what we've seen in the past is making a request through the web server. Let's say you put a tick within one of the parameters, and you'll get back an Oracle error message. So what I see this all the time with web services is that I rarely see an error message that's redacted. So we will have, typically a stack trace, or in this case, the Oracle error code, which basically leads to error-based SQL injection.
So yeah, I mean, when you take it to the next level, you actually could look at logging in with a valid username and password. So as opposed to the username enumeration before, we were just using a bogus password. Now we're using an actual valid password and looking at the responses. So we can just keep going. Here's a username brute forcing tool over SOAP. And then looking at CMC app, web application, standard, just log in and just pass the credentials that you're looking for. And then from there, you can actually get access to the application. Next, we actually looked at identifying some other vulnerabilities in the applications, one of which being reflective cross-site scripting. So apparently they were basing it on access to, and apparently they already knew about this vulnerability by the time we got to them, so kudos to the other researchers. But we found that the input validations was not sufficient, so easily susceptible to reflective cross-site scripting and persistent cross-site scripting as well. So what you would do here is basically just modify that, the input to basically transmit the session identifier back to the attacker, log into the application as them, and then perform another attack. We also found that it was susceptible to persistent cross-site scripting, which is a little bit worse, but when we talk about implications, we'll get into that a little bit, we don't yet know about the implications. So here we've basically modified one of the parameters, and we're just simply going to pass a text box pop-up window with the session identifier. So bing, there we go, session identifier, good enough, and we can continue the attack.
So yeah, cross-site scripting, great, but let's be honest, on a one-week pen test, chances are I'm probably not going to leverage it. It's something I'm going to know, talk to the customer about the risk. So what I'm really looking for is remote code execution. So one thing CMC app provides, or the BusinessObjects provides, is it's called a program job server. Basically, you can set it up to run something for you, so I can say, here's this batch script, run this in 2 minutes. Or you can do a little more complicated stuff, so I've created a report, FTP it out every time I create the report. But the thing is, it's really liberal with what it'll take in, so you can feed it an interpreter, exe, or whatever you want to feed it, and it will just run it for you, schedule. The only caveat is we need administrative credentials. So if you're in a situation where maybe you've obtained administrative credentials and you want to root the system in order to pivot with it, you can use this attack. Generally we found the information out there is kind of all over the place, so different admin guides. So these next 2 slides are basically just for reference if you want to use this attack. Again, how to set up the program to get it going once you have the credentials.
So the important thing to note if you take a look at this slide is that it may or may not be enabled currently. So if you've got access to the administrative interface, you may or may not be able to actually utilize remote code execution through CMC app. So then we started to look at the DSW Bob.JE because of the fact that, look, we have cross-site scripting, or we have persistent cross-site scripting either or, and or maybe there's a default username and password. What implications does that have? What can you do as an attacker? So the idea is web services, it's sort of a requirement to actually be deployed, if you're going to be doing web services communications on the network. So you need to actually install this particular module. So it's a WAR representation. And then from there, obviously it requires Tomcat. So on the back side, you have Tomcat manager vulnerabilities, Tomcat, and then from there you can get remote code execution that way. But obviously it also opens up the administrative interface. So, they weren't really thinking about that when they actually deployed SAP BusinessObjects in an organization based on the fact that it isn't noted in the documentation. So there's a particular username and password, this default credentials, to basically be able to log into this interface. There was no recommendation in the documentation that we found to basically change or modify this particular information. And then from there, what we can do is we can look at various types of attack vectors. So we have the administrative interface. What can we do with it? Well, we can administer web services. Well, what does that mean? We can look at potentially modifying, deleting web services, and or adding our own. So is there an implication to get remote code execution? Well, as we found, there is. So I think it's almost time for a demo, but here's just a quick proof of concept, basically being able to construct your own web service, which is malicious, and then from there just saying net user add, foobar add, and then just simply upload it. A little bit too big. I'm going to go through this a little bit. Okay, so this is the web application interface. So this is the DSWS, the whole web services interface. So here we see that there's a username and password. We redacted the password, but can't see it and such. But once we log into the application, you'll see that we're going to be able to have the ability to get remote code execution. So the setup for this is Tomcat is currently running with this deployment, and then we're going to upload our malicious web application, and then from there just restart the service.
Yep. And the very fact that you deployed web services, so if you're using this in the environment, it means you're going to have this interface. So you're immediately exposed to risk of that.
Absolutely. Okay, so here what we see is, here's the location for the upload. So we see that there's nothing down here, so there's no new jars, there's no new information. And this is just Tomcat running in an interactive mode. So just to be able to prove that yes, we are running it, and then we're going to just restart it afterwards. Okay, so there's nothing there, no tricks up our sleeve. We log in, and then from there, we go into uploading the malicious web application, or web service. So this is just going to run the calculator. Upload successful. Okay, so we have it. Sample calc is there. Now we're going to just restart the web interface. This is the Tomcat interface. And there we go. No code execution. So the implications, when we actually talk about implications, is if you think back to previously, we had the cross-site scripting vulnerabilities, the persistent and the reflective, or we have the default username and password. So the implications here is that you can have remote code execution by uploading a malicious web service. So pretty much game over. At that point, we have achieved our goals. But thinking back, you need the default administrative credentials to still be in place. And you also do need the ability to have the interface restart. So the denial of service attack may also come as a handy vector, in addition to the fact that Tomcat is a little bit memory intensive, or sort of likes to consume a lot of memory. So if you could just convince an administrator to restart the interface, and then from there we can get the remote code execution we were looking for. So instead of the calculator, we just use an interpreter, and then a whole lot of different attack vectors come into play. So again, to change the credentials location, and it's currently installed by default, and it will be there. Yeah, that's pretty much everything on that. The other thing I should mention is we did contact SAP beforehand, and they were responsive, and they were also going to put out some documentation about how to actually go in and modify and change these default credentials. And we thought that was that in the essence is the vulnerability, the fact that they're not making it as clear that there's this username and password, and the implication is that if you don't do that, then I can do something such as upload this malicious web service and get remote code execution.
They have a patch going through the marketplace too, right?
I believe so, yes. Yeah. So, yeah, we're still waiting on that information. So, you wanted to do the summary?
Summary, basically going over the technical methodology for pen testing, SAP BusinessObjects. Hopefully you find it useful on site. So the idea was kind of taking the methodology you're using and apply it to a product. If you see this on site, how can you leverage it to really obtain your goals? Again, SOAP was a big portion of what we're talking about, but again, that was one of the two interfaces that we chose. So you could have done another interface if you want. Security Advisory coming out 12th, and then the Metasploit modules will also be coming out then.
So we'll also link back to the SAP announcement if they make an announcement, so that anyone who's actually deployed a BusinessObjects instance would be able to modify the username and password. So sort of get a preview version of the can't make any promises on that side. Sorry. However, I'm sure many customers wouldn't be too happy about that. But we do see it deployed, and we've actually seen it deployed publicly. So you've seen these same interfaces publicly accessible on the internet.
Like that access to login, you'd be surprised when you can find like a block.
So with the remote code execution, it's how useful do you think a shell is a little bit later? But I mean, you're waiting till the box restarts and the content interface restarts, and then you get the remote code execution you're looking for. So if I get a shell today, or I may wait a couple weeks, well, depends on the rules of my engagement. But it may be within your time window, or you can just pause it and restart. In which case, do it TOS. So yeah, do we have questions? I don't know how we're doing on time.
You actually did pretty good. You got 10 minutes.
Oh, okay. So we're doing perfect then. So who's got questions? Come on, you guys got to have some questions.
Y'all presented as well.
Thank you. Appreciate that. Yes.
So there's like absolutely no way to disable this web interface?
Disabling this web interface? Well, technically it's not deployed by default, so you have the choice to enable it or not. And then you can also modify the default username and password, basically not allow for somebody to easily log in and then perform the remote code execution.
The way you made it sound was you would deploy this web interface as kind of a side effect, so that many people might not even be aware of that misunderstanding.
Yeah, it's interesting. The implication is that when you deploy this web services interface, the administrator doesn't really have any need to go in and log in and modify anything or use that web interface at all. It's fairly less than useful, or not as useful for them, but doing customer engagements, they have this interface that they didn't even know about. So that's that's sort of the implications there is, okay, well you have this default username and password. Well, did you even know? It doesn't really matter. So obviously we demonstrate yes, it does matter. Remote code execution is fairly serious, but really just talking about implications for getting access to the system. So maybe we should put that back up. Any other questions? No? I guess that's pretty much everything. And you can find us on Twitter at Rapid7. Blog a lot, tweet a little bit, and we're going to be in Barcelona for a couple days. We'll be around. So if you have any other questions, feel free to come by and say hi. Excellent. Well, thank you everybody.